Welcome everyone to another video related to the solution of one of the problem which is being taken from the second chapter of force vectors in the book of engineering mechanics, the statics part by R.C. Hibbeler. In this problem, we are being asked to determine the magnitude and resultant force that is being caused by the two forces F1 and F2, and also we are being asked to determine the orientation of the resultant force that should be measured clockwise from the positive x-axis. So let's solve this problem. So let's take the member on which the forces are acting. And this member is being subjected to the three forces, but we are not interested in the F3 force since the resultant of F1 and F2 forces is required in this problem. Therefore, let's apply the F1 force, which makes an angle of 30 degree with the positive x-axis, the F2 force, which makes an angle of 45 degree with the negative y-axis. So first of all, we are going to determine the magnitude of the resultant force caused by these forces. For that, we are going to use the cosine law. And if you remember, the resultant using the cosine law is being calculated by this formula. The resultant force in the under root, we have F1 square plus F2 square plus 2 F1 F2 cos alpha. Now alpha here is actually the angle between F1 and F2 force. In this case, this is the angle I'm talking about. You would have seen another formula where instead of plus sign here we have negative sign. In that case, we have to follow the parallelogram law, and the angle being formed by the two forces using the parallelogram will actually be the theta. But in this case, the angle is actually the angle between the two forces. That's why I've used a plus sign here. So by simply putting the value of all the variables in this equation, we can determine the resultant force. The magnitude of F1 and F2 force are given, but we have to do bit of geometry here to have the angle between the F1 and F2. So if this is 30 degrees, so the remaining will actually be 60 in order to have 90 between x and y axis. So this is actually 60. So the total now will become 105 degrees. So the angle between these forces is actually 105 degrees. Now we just have to put the values of F1, F2 and alpha in this equation. We will have the resultant. So on doing calculations, we are going to get the resultant as 463.7 Newton as the resultant of F1 and F2. Now after having the resultant of F1 and F2, the next thing that we are being asked is its orientation, and that should be measured clockwise from the positive x-axis. Now before having the orientation of the resultant, we have to speculate the direction of the resultant force caused by these forces. Now if you look here, you can see the magnitude of the F1 force is 400 Newton, which is greater than F2, which is 360. The other thing that you can see here is it's more towards the right hand side, and since the angle is 60 in this case and in this case is 45. So we can say then the direction of the resultant force will be more towards in this quadrant just because of more magnitude of the 400 Newton force, and also its direction which is more towards right hand side. That's why I drawn the resultant in the quadrant of this one, not in this one. Now once we have the assumed direction of the resultant force, then using head to tail rule, we can place the tail of the second force to the head of the first force and then joining them together to form the resultant. So this is what I'm saying. So I just displaced the F1 force to put at the head of the F1 force. So as a result of that, we have the triangle where this side is F1, this side is F2, and this side is actually the resultant. So we have just calculated the value of the resultant force, which is 463.7 Newton. Now we want this theta, which is actually the angle measured clockwise from the positive x-axis, means this angle we need. So this angle can be calculated if we can just calculate this interior angle of this triangle. So the interior angle of this triangle can be calculated using sine law. For that, we should know the other known angles. Since we don't know this angle and we don't know the direction of the resultant force, therefore we cannot determine this interior angle. But this interior angle can be determined using bit of geometry. Let's see how. Let's say that this is a parallel line which is parallel to the positive x-axis. So you can see here that 30° here will have same angle on the other side. So this angle would be 30°, and this F2 force makes an angle of 45° with a positive y-axis. Therefore, it should make 45 degrees with the positive x-axis, or the x-axis we can just say. So as a result of that, you can see we have this interior angle as the addition of these two, and that makes it 75 degrees. So once we have that, then we can determine this interior angle using sine law. So what's the sine law then? So let's say that this interior angle is beta. So then sine beta would be divided by the magnitude of the force in the opposite side, which is F2 in this case. So it means 360. Now this should be equal to sine of interior angle, which is known, and we just have come to know that this interior angle is 75 degrees. This one is not known, so that we are not going to take that. So this would be divided by the force on the opposite side, and that's actually the resultant force, which is 463.7. So in this equation you can see that there's only beta as the variable. So if you can do the basic calculations, then you can determine the beta angle as, so the value will come out to be 48.58 degrees. So we just have now calculated the beta, but we are interested with this angle theta, which is actually the angle this resultant force is making with the positive x-axis clockwise. So this theta will then be equal to 30 plus the interior angle, which is 48.58 degrees. So on adding them, we will have 78.58 degrees as the angle which the resultant is making with the positive x-axis measured clockwise. So this is how the calculations would be done when we are being asked to determine the magnitude of the resultant force caused by the two forces. Their directions are given, and also we are being asked to determine the direction of the resultant force with the positive x-axis. I believe you can understand what I have done right now. If you think there is something which I have overlooked, or you feel that there is something that you need to ask, then please let me know through the comment section so that I can get back to you. So that's all from this video. Thank you for watching this video. I hope to see you in next coming videos. Till then, bye.